So this is Mechanical Science Sheet 4, Question 3, Part 2. So we discussed how to solve for the mass earlier, or how to use the mass in the torque equation. It's similar to the way we always tend to use it. We always tend to use cos, but it was just like to reiterate it. So we're going to work on the tension next. So basically, as you can see here, this red dot shows the line that goes perpendicular to our beam, and you can see it makes a right angle with the beam. This green part here shows that the tension makes an angle from that perpendicular line, and that angle is the angle we need to use for our torque equation. So to find that angle, we say, okay, we've got a full triangle here with 30 degrees, and an unknown angle. We know that each triangle has a total number of degrees of 180. So we can say this angle here is 180 minus 30 minus another 30, which gives us 120. So now we have 120 as this whole angle here. If we take away 90 degrees for this red part here, the right angle, we're left with 30. So we know that this green angle is 30. So I've just written that out here just to reiterate. And as you can see here, the reason we're doing it is because normally if our force acts this way, perpendicular to the arm that we're acting upon, then all the force is transmitted. But in our case, not all of it is. So we need to use this angle. And this angle here, hopefully you can sort of imagine this being moved around slightly in your mind, but it's this angle. So we use L, which is the total length of this beam, T, which is the tension, and cos 30, because we just solved for 30 over here. And that's equal to mg L divided by 2, because mass is acting halfway along the beam, and cos 30, because what we discussed earlier. So you use this and you rearrange for t, and that should give you the correct answer.